All right, let's look at this problem on inverse functions. So the first thing I would do on a problem like this is to graph it. So I'm going to put in the function. So there I see the graph, and what you want to be able to do here for the inverse function, the line y equals x is going to act like a mirror, and I'm going to hold this down and make it a dashed line. So this is like a mirror for the inverse function. So I know that any point that's on a graph of a function, just flipping those coordinates around, the 0, 1, is going to be on the inverse. And this function that, it rises and turns hard to the right, you got to act like this is a mirror. So this function that I'm going to see is going to rise really quickly vertically, and that's going to be the inverse of this function. So the process is to treat this like y. F of x is the same as y. So like grabbing this equation, copy, and I'm going to paste it down here. And you can do this on paper, obviously. Calling this y, and then replacing y and x. So I'm going to replace, everywhere I see an x, I'm going to replace it with a y, and everywhere I see a y, I'm going to replace it with an x. And that's going to be the inverse of this. All right. It's just that instead of leaving it like that, we solve for the new y. Okay, we're going to solve for the new y. Now the problem is we're going to end up squaring this, and when we do that, notice that now we get both sides of that parabola. Okay, that's what happens when you square this thing. We end up with more things can work. So what I mean by that is you can't take the square root of negative. So this y couldn't be less than 1. 1 had to be the biggest thing it could be, because anything below that, we take the square root of a negative. Like, for instance, 0. 0 minus 1 is negative 1, and we'd be taking the square root of a negative number, and you can't do that. But on the next step, where I've squared both sides, the square root's gone, and I don't have that restriction anymore. So they end up being the same thing on the right-hand side, but it's now we have points on the left that we couldn't get before because of the square root. So this graph is what we're looking for. It's just we need to solve it for y, right? And ultimately I'm going to get y equals x squared minus 1, or sorry, plus 1, when I add it to the other side. You can see that's still the same graph as the other one. It's just that we have to restrict it, right? Notice this thing right here doesn't have anything to the left of it. There's no negative x's here. So I'm going to put in a little set bracket, x is greater than or equal to 0. Close that off, and you'll see now it only gives me, let me turn that off, it only gives me that right hand side. Right? It's showing all those dots are intersections. It actually intersects everywhere. But anyway, that's now the intersection. And this is what it's asking for on this problem. What is the inverse? The inverse is, it's actually down here. The inverse is x squared plus 1, but x is greater than or equal to 0. That's the inverse. And then the second part, I want you to graph them together. So we've already seen B is going to be the graph, but the reason why you know it's B is because we graph the first one, and then we think of a mirror image around that line y equals x. So they've got the line y equals x there in green, so you can see that this is the only one that's a mirror image across that line. Now that's a mirror image on D, but that's a mirror image across the x-axis, and that's not what inverse functions don't have that property. All right, now the domain and range, that again you can get from the graph. The domain of the original function are all the x coordinates. And let me change the color of this so you can see the difference between the two. But the domain of the red function is from 1 to infinity. That's the first x coordinate we see, and then we just keep on going to the right and we have graph above it. So that's the domain of the original function. The range of the original function are all the y coordinates we see. So the smallest y coordinate I see is 0, and then I see all positive numbers. So the domain is x is greater than 1. The range is y is greater than 0. That's just the opposite for the inverse, and that's the property with the inverse function. The domain here is x is greater than 0 for the inverse. So we have the smallest x coordinate of 0, and everything to the right of it has an x-coordinate with a point on the graph to the right of 0. And the y-coordinate, now there is no y-coordinate of 0. The smallest y-coordinate is 1 to infinity. So the domain and range flip here. So the domain of f is, we need 0, comma, infinity. Or the domain of f is 1, comma, infinity. And that's the range of f inverse. And then the domain, the range of f, which is the, I got that stated incorrectly for A. The range of f, which is the domain of f inverse, is 0 to infinity. All right, again, you can see it on the graph. The domain of f, the red graph is f, is 1, the x-coordinate, to infinity. The range is 0, the y-coordinate, up to infinity. Now turn that one off. Now we're looking at f inverse. The domain starts at 0 and goes to the right. The range is 1, the y-coordinate 1, and it goes up.